All right, in this video, we're going to take a look at dividing with our decimals. So if we look at the standards mastery questions that you had, the first standards mastery question says, which equations are true when you take 3/10 and you put it in the blank spaces that they give you below? So in some of these cases, your 3/10 could be your dividend, your divisor, or your quotient. In this first one, they want you to take 3/10 and divide it by 1 5/10 and see if it actually equals 2. If I'm estimating in my head and I put 3/10 in this place and I divide 3/10 into smaller groups, is it realistic that I would end up with 2 wholes? Probably not. Let's go ahead and go through our long division steps though and see if we are on the right track with our estimation. 3/10 divided by 1 5/10. When we set up our long division problem, we're going to put our 3/10 inside our division sign. Our 1 5/10 is going to go on the outside. We can't be dividing by something that has a decimal in it. We need to make sure we're dividing by a whole number. So in order to do that, we're going to move our decimal to the right, one place value, to make this a 15. Whatever we do on the outside of our division sign, we need to do on this inside of our division sign as well. So since we move this decimal one place value, we need to move this decimal one place value as well. So now, if it helps you to see it rewritten, we have 3 divided by 15. So we know automatically if we have 3, which is smaller than 15, but we're taking 3 and dividing it into 15 groups, our answer is going to have to be less than what we started with. It's going to have to be less than 1. We're going to put our decimal up in our quotient. 15 is going to go into 3 0 times. It's important to put your 0 there to hold that place value. We're going to add a 0 next to our 3 here. Now we can ask ourselves, how many times will 15 go into 30? 15 will go into 32 times. It's important to make sure you're putting that 2 on top of your 0. 2 times 15 gives you 30. When we subtract, we have no remainder, we have nothing left over. So we are done. So we know that our answer, or our quotient, is 2/10. If we take a look at the same question, only we look at it with partial quotients, which literally just means part of your answer, or part of your answer for a division problem. And we have 3/10 divided by 1 5/10. When we set up our division problem, we're going to have 3/10 on the inside of our division sign, 1 5/10 on the outside. Only now, since we're doing partial quotients, we'll bring a really long line down so that we can do our repeated addition of our answer on this side of it. We're still going to do our same thing with our decimal and move it over one place each. So we're going to be left with 3 divided by 15. We know that 15 isn't going to go into 3 at all, so we're going to go ahead and add a 0. Put our decimal up in our quotient. Let's say we're thinking that 15 is going to go into 30. On the top of our head, we can think 1 time. So 1 times 15 gives us 15. If I subtract, I'll get 15 again. 15 goes into 15 1 time, and 15 minus 15 would give me 0. When I add my answers over here, it's going to add up and equal 2. And I always, when we're dividing by decimals, want to take my answer and put it as far to the right in our quotient as possible. So our 2 is going to go all the way over here. So we're still going to be left with 2/10. If we go back to look at what the answer they gave us, 2/10 here is not the same as 2, so this one would be a no. If we take a look at our next question, we need to divide 9/10 divided by 3/10, and we need to see if that's going to equal 30. So this one we'll set up with long division. 9/10 divided by 3/10. We can't divide by a decimal. We need to make sure this is a whole number, so we're going to move our decimal one place to the right. Whatever we do here, we need to do on the inside as well, so we're going to move our decimal one place to the right. Now we're dividing 9, put our decimal in our answer. Now we're dividing 9 by 3. Well, how many times does 3 go into 9? I know that 3 goes into 9 3 whole times. So I'm going to put my 3 above my 9. 3 times 3 gives me 9. When I subtract, I have nothing left over. So my 3 is actually a whole number here. They wanted to know, is your answer going to equal 30? We know that it equals 3, so this one would be a no. Okay, let's take a look at our next one. We have 15 divided by 3/10. They want to know if that's going to equal 30. We'll set this one up with partial quotients. If you did long division, that's okay too. So we have 15 divided by 3/10. We've said we can't divide by a decimal here. Our 15 is a whole number. It actually has a decimal. Every number has a decimal. It starts to the right of that whole number because we have our 5 in the ones place. In order to make this a whole number 3, we need to move our decimal 1 place to the right. Since we moved it 1 place to the right here, we need to move it 1 place to the right here. There's no other number here to hold that place value, so we're going to go ahead and add a 0. So now, if we erase our decimals so that they're in the correct spot, we have 150 divided by 3. I'm going to go ahead and put my decimal up in my answer. Since we said we're doing partial quotients, we're going to bring our line all the way down. Off the top of my head, and you might be using different numbers, I know that 3 can go into 150. Well, I know that 3 times 10 would give me 30. So I'm going to line up my ones place and my tens place. When I subtract, I'm left with 120. What else could I subtract out? Maybe 10 again, or could I think of something bigger? Well, I know that 3 times 2 is 6. So 3 times 20 would be 60. Maybe I'll subtract that out next. 0 minus 0 is 0. I can't do 2 minus 6, so I'm going to regroup from my hundreds place and make it a 0. Since I'm adding 10 to the tens place, my 2 becomes a 12. 12 minus 6 gives me 60. I already know from the last one that I just did that 3 times 20 gave me 60 here. So I'm going to use another 20 here, and 3 times 20 will give me 60 again. When I subtract, 0 minus 0 is 0, and 6 minus 6 is 0. So I'm left with nothing. Now I need to go ahead and add up the parts of my answers. 10 plus 20 plus 20 all together should give me 50. So when I go ahead and put my answer up in my quotient to figure out if the decimal's in the right place, I need to line up my place values all the way to the right. The right place value is here. So my 0 is going to line up with the ones place in my 150, and my 5 is going to line up in the tens place on top of my 150. So my answer here is going to be 50, which, if we go back to our problem, is exactly what they told us our answer should equal, so this one would be a yes. Okay, for the sake of time, we're not going to go through the rest of those, so let's take a look at what else they give you. In this question, you need to decide if the image represents each one of these equations. So we need to figure out, is this picture showing you, in this first one, are they showing us 4 divided by 6 equals 7/10? So if we look at our picture, we have 4 whole, each one of these larger boxes represents 1 whole. So we have 4 of these, so that 4 makes sense, but are we dividing them by 6 groups? I'm not seeing that. We're not dividing these into 6 equal groups because we have some part left over on this side. So if we were dividing them into 6 even groups, we would be dividing the entire 4 wholes into 6 even groups, and we wouldn't have any leftover part that's unshaded. So this would be a no. Are they showing us 3 and 5/10 being divided by 7/10? Let's look and see what they're showing us. Altogether, how much is shaded in? We have 1 hole, 2, 3 holes, and let's see, 1, 2, 3, 4, 5/10. That's completely shaded in, so that part makes sense. Are they dividing it into groups of 7/10? Each one of these larger black lines is showing you what they're dividing it into. In between each one of these sections that's broken up by the larger black lines, we have 1, 2, 3, 4, 5, 6, 7/10, which is 1 entire row. So this is showing us 3 and 5/10 divided by groups of 7/10. Do we have 5 groups of that? 1, 2, 3, 4, 5. Yes. So this one would be a yes. Okay. Here we want to know, are they showing us 7/10 times 6? So are there 6 groups of 7/10? Well, we just said in between each one of these black lines, there's groups of 7/10. There's 1, 2, 3, 4, 5, 6, 7 whole rows, or 7/10. Do we have 6 groups of that? There's 1, 2, 3, 4, 5. There's only 5 groups, so there's not 6. So this would be a no. The last one says 3 5/10 times 5 equals 7/10. So let's think about if this equation even makes any sense. We know that we've already mentioned that there's 3 5/10 completely shaded in. There's 1, 2, 3 whole grids, and then 5/10 of another one completely shaded in. We've also mentioned that there's 5 groups of 7/10. So there's 1, 2, 3, 4, 5 groups, and each one of those 5 groups has 1, 2, 3, 4, 5, 6, 7 rows of 7/10. So all of these numbers are being represented in the problem, but are we actually representing this equation? Are we showing that we have 3 5/10 5 times? No. We have 3 wholes and 5/10, but we only have 1 set of those. If we estimate here 3 5/10 times 5, this is similar to doing 3 times 5, which would equal 15, not 7/10. So even though all of these numbers are actually represented at some point in our problem, we're not actually showing this equation. So this would be a no. Okay, let's take a look at what else they give you. This one, it has a word problem. It says Sonia has a stack of pennies that's 96/100ths inch tall. The thickness of each penny is 6/100ths inch. How many pennies does Sonia have? So for this one, we could set this up with long division or with partial quotients. If we do long division, we're taking 96/100ths divided by 6/100ths. We need a whole number here, so we're going to move our decimal 2 places to the right. Since we moved our decimal 2 places here, we'll move our decimal 2 places here, and we're going to put it up in our answer. Now we're just dealing with a whole number 6 and a whole number 96. So if we rewrite our problem, we have 96 divided by 6, and our decimal is up here in our answer. I know that 6 goes into 9 one whole time, and 1 times 6 will give me 6. When I subtract, 9 minus 6 gives me 3. I need to bring down my 6 next to my 3. Now I have 36. 6 will go into 36 6 whole times. 6 times 6 gives me 36, and there's no remainder, there's nothing left over. So my answer would be 16 pennies here. Okay, this next one is showing you another model. It says Grace has 5 4/10 pounds of potting soil. She puts an equal amount of soil in 9 pots. Grace draws this model to show how much soil is in each pot. So we can't see the drop-down menu options, but what we want to make sure we're looking at is in this model, they're showing you 5 4/10. So there's 1, 2, 3, 4, 5 whole grids colored in, and 4/10 of another grid. Then they're breaking it into 9 pieces. So to break these into 9 equal pieces, they're breaking that with the larger black line that they're showing. In between each one of those sections, you have 1, 2, 3, 4, 5, 6/10. So what they're representing in this model is 5 4/10 pounds divided into 9 pots. You should end up with 6/10 pounds of each pot in each one of those pots. So would Grace's model be correct here? Yes, because in between each one of these groups, we have 6/10 being represented. Okay, the last one we're going to look at says, Naomi has a fruit salad mix with 5 pounds of grapes, 1 2/10 pounds of apples, and 1 pound of pears together. She divides the fruit salad into 6 bowls. So before we can do any division, we need to figure out how much fruit there is all together. So she has 5/10 plus 1 2/10 plus 1 pound. So if we remember to add when we're adding our decimals, we need to make sure we line up our place values, and we can fill in zeros with any places that are missing a digit. When we add these, we should get 2 7/10. So this is representing the total amount of fruit that she has altogether. Then it tells you in the problem that she's dividing that equally into 6 bowls. So you need to find a problem that is starting with 2 7/10 and then dividing it into 6 bowls. So let's look at our options. In our first one, we have 1, 2, and 8/10 that are shaded in to begin with. And then you can see with this kind of jagged, darker line, they're showing you that they're breaking it into groups. Without even counting how much is in each one of those groups, I know that this can't be the answer because they're starting with 2 8/10. There's only 2/10 left over. And we know that they should be starting with 2 7/10. In our second option, they have 1, 2 whole grids, and then 1, 2, 3, 4, 5, 6, 7/10 of the third grid. So this could be a possible option as long as they were breaking these 2 7/10 into 6 groups. So how many groups do we see? From the beginning to this dark line is 1, 2, 3, 4, 5, 6 groups. So this one is showing 6 groups as long as the number of hundredths that you had in between those darker lines was the same. This could be a possible option. So let's go ahead and look at our other options and make sure that that's the correct one. In this third option, we have 1, 2, 3, 4, 5, 6 whole models colored in completely. Well, we have a number 6 in our problem, but that's because we're breaking our amount of fruit into 6 groups. We don't have 6 whole pounds, so this one would be a no. In our last one, they're showing you that you have 1, 2, 3 whole pounds that they're then cutting into these groups that they're showing with the larger dark lines. But nowhere in here do we know that we have 3 pounds of something. We're starting with 2 7/10, so this would be a no. So our correct answer here should be this second model.